So today's lesson, we're going to learn how to apply, or the application of compound inequalities and how it applies to real life problems. So our goals for today, we want to identify whether a real world scenario represents an and or an or compound inequality. We're going to translate real world verbal constraints into algebraic compound inequalities. And we're going to solve and graph applied compound inequalities to find the set of viable real-world solutions. Okay, so let's take a look at some keywords. Okay, if you see anything that says outside of, or if it says under blank or over blank, if it says below blank or above blank, or special discounts for kids or seniors, these are all going to be our union or our or statements. Okay, this means there are two separate individuals or intervals that we graph and usually shades away from the center. Keywords for our and compound inequalities or our intersection. Words like between or must be within or a minimum of blank and a maximum of blank or a safe operating range. These are all some keywords you need to pay attention to as we read through our different story problems. Remember, this is a single bounded interval like a sandwich. You graph and shade between the two endpoints or our boundary points. Okay, so let's take a look at our first example. Well, first off, the steps. First, we're going to identify the type of compound inequality. Is it or is it and? We're going to set up the compound inequality and then solve it and graph it. So for our first example, we have, let's move this picture of me. A greenhouse heating and cooling system keeps the indoors temperature within a specific range to protect sensitive tropical plants. The plants thrive when the temperature is between 62 degrees Fahrenheit and 78 degrees Fahrenheit, inclusive. Okay, so that means it can be 62, it can be 78, or it can be anything between those. Okay, the greenhouse's automated temperature control is governed by the expression 3t minus 4, where t is an environmental control setting. Okay, are we going to be using or? Oops, that is not what I meant to do. Back to you, gotta click my marker. Are we going to be using or are we going to be using and? Well, it said, one of our keywords, it says between. Okay, so if we go back and look at our keywords, where was between? Between was right here using an and in a compound. So if I come back, we know we're going to be using the word and or a sandwich type inequality. Okay, so the first thing I'm going to do is I'm going to identify the low point of this temperature. And the low point is going to be 62 degrees. So I'm going to put a 62 first. And since it is inclusive, that means I'm going to say less than or equal to, because that means the 62 can be part of the solution. Okay, what's the high end of the temperature? The high end is going to be my 78 degrees. That's the highest it can be. Okay, and then what goes between? What's the third term between? It's the expression that they gave us, 3t minus 4. Okay, so we have it set up. It was an and. We found our low temp and our high temp in this case, and the expression that goes in the middle. So let's go ahead and solve this equation. So we're going to add 4 to both sides. That disappears because it cancels out. 62 plus 4 is 66. Is less than or equal to 3t. Is less than or equal to 78 plus 4 is 82. All right. Now at this point, we're going to go ahead and finish it off by dividing both sides by 3. All 3 sides by 3. So 66 divided by 3 gives me a 22. And an 82 Yeah, 82 divided by 3 gives me a, let's see, 90 divided by 3 is 30. Oh, it's going to give me a decimal. That's fun. So it's going to give you a decimal of 90, 87, 27.3333. Anyway, hopefully they're not like that. They're good on your assignment. You have decimals, but that's what I would be. So I have a critical point at 22. I have a critical point at 27.333. And then we're going to go ahead and fill in both the circles because they both had less than or equal to. And then we're going to go ahead and fill in between them for our graph. All right, so there is our first example. Let me know if you had any questions about that one. Sorry about the decimal. That's just the way it ended up working out. Okay. A dry ice storage unit has a safety alarm. The alarm sounds if the internal temperature drops below negative 40 degrees Celsius or rises above 10 degrees Celsius. The temperature of the unit is modeled by the expression 2x plus 6, where x is a dial setting on the cooling value. All right, so is this going to be or is it going to be and? Well, it says the temperature has to be below 40 or above 10 degrees Celsius. So clearly, we're going to be using an or compound inequality, which means we have to have two separate statements with the word or between them. So we're going to use the first expression, or the expression 2x plus 6. And we don't want that to ever get below negative 40 degrees Celsius. Okay? And then we're also going to take that expression of 2x plus 6, and we don't want that to ever get above 10 degrees Celsius. So now we have our two different expressions. Let's go ahead and solve these. So we're going to minus 6 from both sides on this first one. We get 2x is less than negative 46. Divide both sides by 2. And we get x is less than negative 23 for our first boundary point. All right, over here, that's minus 6 from both sides. 2x is greater than 4, because 10 minus 6 is 4. Let's go ahead and divide both sides by 2. And I get x is greater than 2 for my next boundary point. Okay, so we're going to graph these. So we're going to put a boundary point at negative 23. And it's filled into it's shaded to the left. And it's an open circle because we don't want it ever to drop below that. Okay, so we're going to use an open circle. And over here, we're going to have an open circle at 2 being shaded to the right. Once again, it is an open circle because we don't want it to go above that amount. Okay, so this is non-inclusive. Doesn't include those endpoints. So there is an example of an or compound inequality. Let's try another one. All right, to buy season pass and lunch at Lagoon Amusement Park in Utah, a student estimates they need to spend a minimum of $85, but they have a maximum budget of $125. The total cost can be modeled by the expression for x plus 5, where x is the number of individual ride photo packages they can purchase. Okay, so is this going to be or is it going to be and? Okay, this one is going to be an and inequality statement because basically they have it's between a minimum of 85 and a maximum of 125. So the minimum is 85. The maximum is 125. So since it's a minimum, is that going to be inclusive? Yes, I have $85. It's going to be less than or equal to. You have to pay a minimum of $85. Let's put our expression in the middle. And then we have a maximum of $125. So we can spend exactly $125, which means it's got to be less than or equal to. All right, so we have our inequality set up. And now we want to see how many pictures we can buy at Lagoon on the rides. It was $85 to get in. Let's see how many pictures we can take. So we're going to minus 5 from both sides, all three sides. And we get 80 is less than or equal to 4x, which is less than or equal to 120. Okay, divide everything by a 4. And I'm going to come over here because I ran out of room. 20 is less than or equal to x is less than or equal to 120 divided by 4 is, oh man, 10, 20, 30. Took me a second to figure that out. All right, so here is my inequality right here. So that means I can purchase anywhere between 20 to 30 pictures. Okay, so we have a boundary point at 20 that is filled in. A boundary point at 30 that is filled in. So we can take anything between 20 to 30 pictures and pay for those, which is not reality because those pictures are actually pretty expensive at Lagoon. But anyway, that's what the story problem says. Okay, so there's that one. Let's do last one. A shipping company charges extra handling fees for packages that are either very light, under 2 pounds, or, hopefully that gives you a hint, very heavy, over 45 pounds, requiring a manual team lifting. The container's weight is separated by 3W minus 7. So, since it's an or statement, that means we're going to have two separate inequalities separated by the word or. So, under 2 pounds. So, we're going to take the 3W minus 7, because that is my expression. And it's got to be under 2 pounds. So, less than 2. It doesn't say less than or equal to. It has to be under 2. That's why we can't put the equal sign. Or 3W minus 7 has to be greater than 45 pounds. Okay, so it's extra handling fee if it's below 2 pounds or above 45 pounds. Why? I don't know. Maybe they don't like small packages on their ships. So let's go ahead and solve for trucks. Let's go ahead and solve this. So we're going to add 7 to both sides on this one over here. We get 3W is less than 9. Divide both sides by 3. W is less than 3. Over here, let's add 7 to both sides. And we get 3W is greater than 52. All right, so let's go ahead and divide both sides by 3. And we get W is greater than, we get another decimal on this one. Yay, 17.3 repeated. Okay, so we have a boundary point at 3. Once again, I apologize. I think the ones on your assignment won't have decimals. Should have double checked that. But 3, open circle, going to the left. 17.3333 repeated, open circle, going to the right. Okay, so that is your inequality and the graph. Once again, here was our goals. Identify whether a real-world scenario represents an and or compound inequality. Translate the real-world verbal constraints into algebraic compound inequalities. Solve and graph applied compound inequalities to find the set of viable real-world solutions. So, for example, if I go back to here, this was talking about the pounds that your package can weigh. For that, we were talking about how many pictures you could take. If you have any questions, please reach out and let me know. Hit stop. That was a bad video.